Hi, welcome back to my channel. I am reading out loud Python Programming: An Introduction to Computer Science by John Zelle. It's the third edition, so if your edition is a little different, there might be some small differences. Today I am reading the preface. The preface is going to help us compare this book to the two editions prior to it. And jumping right into it now. This book is designed to be used as a primary textbook in a college-level first course in computing. It takes a fairly traditional approach, emphasizing problem-solving, design, and programming as the core skills of computer science. However, these ideas are illustrated using a non-traditional language, namely Python. In my teaching experience, I have found that many students have difficulty mastering the basic concepts of computer science and programming. Part of this difficulty can be blamed on the complexity of the languages and tools that are most often used in introductory courses. Consequently, this textbook was written with a single overarching goal: to introduce fundamental computer science concepts as simply as possible without being simplistic. Using Python is central to this goal. Traditional systems languages such as C++, Ada, and Java evolved to solve problems in large-scale programming, where the primary emphasis is on structure and discipline. They were not designed to make writing small or medium-scale programs easy. The recent rise in popularity of scripting, sometimes called agile languages such as Python, suggests an alternative approach. Python is very flexible and makes experimentation easy. Solutions to simple problems are simply and elegantly expressed. Python provides a great laboratory for the neophyte programmer. Python has a number of features that make it a near-perfect choice as a first programming language. The basic structures are simple, clean, and well-designed, which allows students to focus on the primary skill of algorithmic thinking and program design without getting bogged down in arcane language details. Concepts learned in Python carry over directly to subsequent study of system languages such as C++ and Java. But Python is not a toy language. It is a real-world production language that is freely available for virtually every programming platform and comes standard with its own easy-to-use integrated programming environment. The best part is that Python makes learning to program fun again. Although I use Python as a language, teaching Python is not the main point of this book. Rather, Python is used to illustrate fundamental principles of design and programming that apply in any language or computing environment. In some places, I have purposely avoided certain Python features and idioms that are not generally found in other languages. There are many good books about Python on the market. This book is intended as an introduction to computing. Besides using Python, there are other features of this book designed to make it a gentler introduction to computer science. Some of these features include: number one, extensive use of computer graphics. Students love working on programs that include graphics. This book presents a simple-to-use graphics package provided as a Python module. That allows students both to learn the principles of computer graphics and to practice object-oriented concepts without the complexity inherent in a full-blown graphics library and event-driven programming. Second, interesting examples. The book is packed with complete programming examples to solve real problems. Third, readable prose. The narrative style of this book introduces key computer science concepts in a natural way as an outgrowth of developing discussion. I have tried to avoid random facts or tangentially related sidebars. Fourth, flexible spiral coverage. Since the goal of the book is to present concepts simply, each chapter is organized so that students are introduced to the new ideas in a gradual way, giving them time to assimilate an increasing level of detail as they progress. Ideas that take more time to master are introduced in early chapters and reinforced in later chapters. Fifth, just-in-time objective coverage. The proper place for the introduction of object-oriented techniques is an ongoing controversy in computer science education. This book is neither strictly objects early nor objects late, but gradually introduces object concepts after a brief initial grounding in the basics of imperative programming. Students learn multiple design techniques, including top-down, functional decomposition, spiral, prototyping, and object-oriented methods. Additionally, the textbook material is flexible enough to accommodate other approaches. Extensive extensive end of chapter problems. Exercises at the end of every chapter provide ample opportunity for students to reinforce their mastery of the chapter material and to practice new programming skills. There are changes in the second and third editions. So, the first edition of the textbook has aged gracefully, and the approach it takes remains just as relevant now as when it was first published. While fundamental principles do not change, the technology environment does. With the release of Python 3.0, updates to the original material became necessary. The second edition was basically the same as the original textbook, except that it was updated to use Python 3. Virtually every program example in the book had to be modified for the new Python. Additionally, to accommodate certain changes in Python, notably the removal of the string library, the material was reordered slightly to cover object terminology before discussing string processing. A beneficial side effect of this change was an even earlier introduction of computer graphics to pique student interest. The third edition continues the tradition of updating the text to reflect new technologies while remaining a time-tested approach to teaching introductory computer science. An important change to this edition is the removal of most uses of eval and the addition of a discussion of its dangers. In our increasingly connected world, it is never too early to begin considering computer security issues. Several new graphics examples developed through the chapters 4 through 12 have been added to introduce new features of the graphics library that support animations, including simple video game development. This brings the text up to date with the types of final projects that are often assigned in modern introductory classes. Smaller changes have been made throughout the text, including materials on file dialogues has been added in Chapter 5. Chapter 6 has been expanded and reorganized to emphasize value returning functions. Coverage has been streamlined and simplified to use idle. The standard comes with Python development environment consistently. This makes the text more suitable for self-study as well as for use as a classroom textbook. Technology references have been updated to further accommodate self-studiers. End-of-chapter solutions for this third edition are freely available online. Classroom instructors wishing to use alternative exercises can request those from the publisher. Self-studiers and instructors alike can visit https://fbeetle.com for details. That's FBEEDLE.com. That's FBeetle. That's not a real word. All right, coverage options. In keeping with the goal of simplicity, I have tried to limit the amount of material that would not be covered in a first course. Still, there's probably more material here than can be covered in typical one-semester introduction. My classes cover virtually all the material in the first 12 chapters in order, though not necessarily covering every section in depth. One or two topics from Chapter 13, Algorithm Design and Recursion, are generally interspersed at appropriate places during the term. Recognizing that different instructors prefer to approach topics in different ways, I have tried to keep the material relatively flexible. Chapters 1 through 4, computers and programs, writing simple programs, computing with numbers, objects and graphics, are essential introduction and should probably be covered in order. The initial portions of Chapter 5, sequences, strings, lists, and files on string processes, are also fundamental. But the later topics, such as string formatting and file processing, can be delayed until needed later on. Chapters 6 through 8, defining functions, decision structures, and loop structures and booleans, are designed to stand independently and can be taken in virtually any order. Chapters 9 through 12 on design approaches are written to be taken in order, but the material in Chapter 11, data collections, could easily be moved earlier, should the instructor want to cover lists or arrays before various design techniques. Instructors wishing to emphasize object-oriented design need not spend much time on Chapter 9. Chapter 13 contains more advanced material that may be covered at the end or interspersed at various places throughout the course. Acknowledgements. My approach to CS1 has been influenced over the years by many fine textbooks that I have read and used for classes. Much that I have learned from those books has undoubtedly found its way into these pages. There are a few specific authors whose approaches have been so important that I feel they deserve special mention. A.K. Dudeny has always had a knack for finding simple examples to illustrate complex issues. I've borrowed a few of those and given them new legs in Python. I also owe a debt to wonderful textbooks from both Owen Astrachan and K. Horstman. The graphics library I introduced in Chapter 4 was directly inspired by my experience teaching with a similar library designed by Horstman. I also learned much about teaching computer science from Nell Dale, for whom I was fortunate enough to serve as a TA when I was a graduate student at the University of Texas. Many people have contributed either directly or indirectly to the production of this book. I have also received much help and encouragement from my colleagues and former colleagues at Wartburg College. Lynn Olson for his unflagging support at the very beginning, Joseph Brutzman, who supplied many project ideas, and Terry Lecce, who prepared PowerPoint slides for the first and third editions. I want to thank the following individuals who read or commented on the manuscript for the first edition: Russ May, Morehead State University; Carolyn Miller, North Carolina State University; Guido Van Rossum, Google. Hey, Guido is the one who wrote the foreword. Jim Sager, California State University; Chico, State University, Chico. Christine Shannon, Center College; Paul Timon, Rochester Institute of Technology; Suzanne Westbrook, University of Arizona. I am grateful to Dave Reed at Capital University, who used early versions of the first edition, offered numerous insightful suggestions, and worked with Jeffrey Cohen at University of Chicago to supply alternate end-of-chapter exercises for this edition. Ernie Ackerman test drove the second edition at Mary Washington College. The third edition was test-driven in classes by Teresa Migler at California Polytechnic State University in San Luis Obispo, and my colleague Terry Lecce and David Vance provided feedback on a draft. Thanks to all for their valuable observations and suggestions. I also want to acknowledge the fine folks at Franklin, Beadle, and Associates, especially Tom Sumner, Brenda Jones, and Jaron Ayers? Maybe it's Ayers, I'm not sure, who turned my pet project into a real textbook. This edition is dedicated to the memory of Jim Lisi, the founder of Franklin, Beadle, and Associates, who passed away unexpectedly as the third edition was getting off the ground. Jim was an amazing man of unusually wide-ranging interests. It was his vision, guidance, relentless enthusiasm, and a fair bit of determined prodding that ultimately molded me into a textbook author and made this book a success. A special thanks also goes out to all my students who have taught me so much about teaching, and to Wartburg College for giving me sabbatical support to work on the book. Last but most importantly, I acknowledge my wife, Elizabeth Bingham, who has served as editor, advisor, and morale booster while putting up with me during my writing spells. JMZ, which I am assuming and presuming that that is John Zelle. JMZ must be his initials. So I hope you enjoyed that section of the book. What was it called again? The preface of the book. I would like to keep this video nice and short. So please feel free when you are playing back this book to read along the reading to go along with your reading, that you set this to any speed you choose so that you can comprehend the most out of it. I know this wasn't actually the programming material of the book, but still reading comprehension is important. So with that, I will end the stream. Thank you for joining me. Bye.